Hey everybody. A while ago I wrote a completion thing for Emacs that used the OpenAI complete APIs. And I thought I'd give a tour of it. It's been a while since I've read through it, but learned some stuff that I think is kind of interesting, and I figured I'd give a tour and talk about kind of the fun stuff involved. What do I mean by completion thing? Well, I don't really know much Emacs, so I don't know how to work with the completion functionality that is in Emacs. I'm sure there's stuff that would have made this much easier in that, but this is just some mechanism that looks at the text, lets you invoke it while typing, and will invoke the OpenAI completion model and insert the completion. And stuff like compute the primes, whoops, and then hit the go button. And it does the thing. It computes the primes in Emacs Lisp using the common Lisp loop thing. So there you go. That's the kind of thing it does. And I've implemented it to work across Scala, Lisp, and PHP, and show you what that looks like in the Scala universe. Say, print hello world. Pretty classic main. There we go. Right, got our main. A bit more complicated. I don't know. Let's do print hello world plus the args. Oops. Yeah, okay. Call main such that the result is hello world from space. Yep, excellent. The thing you'll note about this is it had to have this in the context, this code in the context for it to know or to complete the function call with space dot from space such that the result is going to work out properly. So keep that in mind. This necessity for context there. What are you complaining about? Oh, so well now here's kind of interesting. This is given a Scala code in the wrong Scala version. I'm in Scala 3, and this is giving me kind of legacy Scala 2 syntax. So that's not cool. But hey, whatever. I guess things have moved fast since this model was probably made. But you get an idea what the completion thing is. It does do enough to often get me along in the right direction while coding in Lisp especially, but sometimes in Scala and including in PHP. And we'll go over how it works. The general idea is that it provides these two instructions to the completion model. One is the system prompt, and then the other is the user prompt. And the system prompt is fixed, and the user prompt is where there's some manner of context inserted into the user prompt for the completion to work well. Now let's read over this system prompt. You get an idea that it preps the language model to look for these segments and interpret them according to kind of the brief description here. And there's some careful instruction to make sure the substitution does what I want when reading the response. Like it really wants to be helpful and explain the substitution and stuff like that. And there is probably room for, integrating that explanation that it spits back out nicely. But I really just want the code. And this is kind of what I need to coerce it to do the code. And you might have noticed that right when I hit the completion button, it inserted XXX into the buffer. Like I said, I don't really know Emacs completion, but this is how I did it to make it do the completion is, I literally execute the code to add XXX, and then it does the substitution of XXX in not the buffer, but around where the request was made for this. That it just sets up what the context specific stuff, the system prompt, and how it's going to be broken up. Again, really only want the substitution, so kind of prompt that again. And then I give it the three levels of context: global, uh, medium length context, and local context. And you can see what I'm trying to do here with those is I want to provide kind of the general structure of the project in the global section. Uh, Stuff that might hint along the naming or the concepts being worked on in this project. The context is more medium level scope or distance from where the completion is being requested, the local area. And that's where concepts and terms and definitions that are closer to the exact code being requested are provided. And then local is straight up the incomplete code with the XXX in there. So that's available for the completion model to give you the substitution for. What is selected for global context and local? I think that's where things get kind of interesting for this. First, this model is nice, giving these three levels of depth. It seems to provide good quality responses. It seems to be an effective technique overall. So, how do we pick in the code what's the immediate code that needs completion, what's kind of the medium length context around it, and what's the global kind of general structure? Might help to start with how I might do this for something I'm really clueless about, which is Lisp. This is pretty much the biggest thing I've written in Lisp. You can see here that I pretty much define the local context based off of a regex. This works pretty much by searching backwards to the biggest match for that regex plus some context forward, so plus some code forward that fits within a certain limit. Pretty dumb, but usually works out okay. I think some additional cleaning, maybe balance, making sure brackets are balanced in the selected code might be a bit nicer for this regex-based one. Even better would be something that uses some information about the parse structure, the abstract syntax tree to figure out the local code. But this is dumb and it works. And then similarly for the medium or context stuff, I grab all the function definitions. And I don't really know how to make a regex to match this in Lisp, but this was close enough to get me all the function definitions. And then for the global one, the global context, what was fairly interesting or fairly effective was to actually just list the other files in the directory. Since typically when I'm working in Scala, which is what I kind of optimize this for, the other files in the directory have names that reflect the concepts that I'm working in. And this just provides those names directly. And it gives kind of an explanation that the code that is being talked about or the medium and the local context is in a file named blank, and there's other files in this project. This was pretty effective at giving kind of tuning the domain language picked by the model to better match what's actually being worked on by having these additional samples available for it. So that's how you might imagine you could grab like a local, medium, and global context for this prompt for a regex-based one. But like I said, that's kind of dumb. So let's figure out a smarter way to do that. And that's what I attempted for the Scala one, which is what I primarily use this for. And you know, I'm not very good at Lisp, but my attempt is to pretty much do like an optional where it's attempting this and then it's attempting this if the prior fails. So the first thing this tries is to get the local context from LSP. And if that fails because LSP is not working for some reason or another, then it falls back on the regex one. And likely, similarly for the medium length context one, it tries to grab information from LSP again. And this has worked really well. Using LSP to query the structure of the file in order to answer questions like, what are all the functions in the file, or what are all the symbols in the file. This has worked great. And it might be interesting to read how I query the LSP responses to figure out this kind of stuff. It works a lot better than regex-based one because the local code that's picked is a complete symbol definition, and it looks for the biggest symbol definition that still fits within some context size, which is just some parameter which you can increase or decrease for this. And is probably worth pumping up the context size. To be honest, I think GPT-4 can handle it, so might as well. Similarly, for the medium-sized context, it again uses LSP, but this time it grabs all the symbol declarations from LSP, and this is much better than matching with some regex. This is very precise, and it just grabs them all. And I think it might limit it. Yeah, it does take a limit on this. So the regex one, it works. It's surprisingly good with GPT-4. GPT-3, 5 kind of works. What is it? I haven't tried some of the other models. The Text DaVinci, it was okay. It's what I originally wrote this for, so it kind of works, but the responses are pretty dumb. It doesn't really, all the responses are pretty dumb in some way. But anyways, using the LSP has worked really well to grab the additional context. It's proved somewhat useful, like I said, usually just for giving some type of idea. I don't use it too often. The biggest problems with these things is providing enough context where they're not just doing trivial stuff. Sometimes that's what I want, some local context only. How do I put this? Some well isolated or well constrained code where the small amount of context that you can give it is sufficient for uh, the problem at hand. That doesn't happen all the time. It works better as a guide or tutor or a concept checker to help you design the system with the much larger amount of context that you can hold in your head than what can be provided on these little prompts. Still pretty useful. Was a fun project. I do not like Lisp. I think that is the biggest thing I've written in Lisp, and I hope to keep it that way. I think I will stick to Scala. Yeah.